Next we'll have Steve Stumbras with Purple Cow Organics. Steve grew up on a family farm, and the family also had several restaurants. He lived his life where food and farming meet. Sometimes he thinks the things that we miss are the things that matter. And that all happens in the soil relating to often unnoticed microbial world that drives agricultural production, enhances fertilizer efficiency, nutrient density, and ultimately the health of the people and animals that consume our crops. Purple Cow manufactures a wide range of plant-based carbon inputs and one liquid biological CX1 that they're now going to be calling Liquid Life. Steve will share insights into the biological functions that occur on every farm and how cultural practices and input selections can help enhance grower profitability. So go ahead, Steve.
Thanks, Kyle. Again, as you said, my name is Steve Stumbras. I'm a partner in the company called Purple Cow. A couple of points before I start. There is a pretty impressive list of speakers here today. Really a lot of wisdom in the room. We did this presentation on Tuesday together, and there were very few, maybe no contradictions in the room. There were a number of times where there's a slightly different way to skin the cat, but I think that the fact that everybody who's going to speak today is going to have such a common message is a credit to Jerry, Kyle, and Sean, because what they've done is bring a lineup of better inputs. And you'll hear me say this over, if you can use better inputs, place them more precisely, apply them more frequently, you can make a big impact in your operation. So I want to thank the folks from Allstate, acknowledge the rest of the wisdom in the room, and then talk a little bit about Purple Cow. Yeah, the housekeeping. That's a broad spectrum biological. That's a broad spectrum biological with a nanoparticle, silica. These are now being changed to Liquid Life and Liquid Life Plus. The reason is legal, can't trademark letters and numbers, and marketing a little bit. When we get to places where we haven't been before, we feel like Liquid Life, liquid biology, says a little bit better what it is, what it does than CX1. So I always start with this and reference this book. It's a book by Seth Godin. And the reason for what I'm going to say now is because we wanted the feedstocks that we use are really important to where we want to get to. But as a small company, we've come to appreciate the fact that it used to be companies would tell customers what to think. Today, customers are telling the customers what to think. And our goal is, if we can get our customers to say they make remarkable products, then we'll stand out in like a field of ordinary black and white cows. We'll stand out like the purple cow in that field. So that's where it comes from. There are a couple of important points about the line, the product line. The most important is that it's a 100% plant-based line. This means it's weed, seed-free, pathogen-free. We're all about the diversity of biology, the balance of fungal to bacterial in all the products. Again, the culture media is designed specifically to get to achieve some of the functions that we're going to talk about today. As was alluded to earlier, there are certain microbes that can digest salt. So it's a no salt input. It has salt mitigation qualities. And then this is perhaps the most important part. These diseases come from the digestive tract of an animal. So by using the media that we do, we don't need to worry about this. You can spray it today, eat your food tomorrow. You don't have any of those issues that sometimes the regulatory people talk about. So quickly, the highlight of the presentation today, the conversations about a decade ago were largely, why would I use a biological at all? The second part of my presentation today is how do you go about choosing the right one for you? And then we get into a little bit kind of the nuts and bolts of where you apply it, how, tank partners, and crop specifics. So I'm going to whip through this really quickly because if you have questions about it, Kyle knows where to get the answer to these questions, but I'm simply going to run through these quickly to highlight all the things that biology does in your operation, whether sometimes we don't maybe fully appreciate it or not. But when you just look at the process of taking nitrogen from a gas to the plant, it goes from a gas to a nitrite, from a nitrite to a nitrate, to an amino, to a peptide, to a protein. The difference between a peptide and a protein is additional carbon chains. You'll hear me talk about carbon minerals in biology all the time. I'm not trying to get you to learn all of this, just simply trying to develop an appreciation for these are the family of bacterias that move from a gas to a nitrite. These are the family of bacterias that move from a nitrite to nitrate, and the list goes on. Every step of the way, there's different microbes that are really important for you to achieve that success. Bugs eat carbon. These are different bugs that are doing the nitrogen fixation, but when they eat carbon, they're going to liberate minerals from that carbon that they're working on. You'll find carbon in the soil, you'll find carbon in your fertilizer, carbon in manure, carbon in the plants that you've previously grown. When the microbes that eat the carbon, they'll liberate the minerals that are tied to that carbon, and that's the start of plant uptake. The crop residue pass is really super important. It's important because you're changing the texture of the plant that you've applied the biology on, which allows you to plant next year's crop at a consistent depth. We all know that getting that plant out of the ground uniformly leads to yield, and the place to start there is making sure your seeds are all at the proper depth. So I'm going to later touch on some of the other benefits of a crop residue application, pathogen control, building carbon, cycling the minerals, but I just want to highlight here.
On the left is the untreated area of the previous year's corn stover. On the right, stover from the area treated with CX1 and Boost. You can see the lighter colored, untreated residue is still sturdy, moist, flexible, and not easily broken down by tillage equipment. On the right, the treated area, the stover is like dried charcoal. It will shatter with the first equipment pass of the season. Watch as Carl bends each of these corn stalks from last season.
Ready? Yeah. It's just amazing, the difference.
That is. That's.
So the thing I really want to highlight there is that's the biological digestion that's going on there that changes that structure. Microbes eat carbon, and whether that carbon's in your soil, in your fertilizer, in your residue, different microbes are the ones that cycle the minerals from one season to the next. So once you take off 155 bushels of corn, you're left with carbon, nitrogen, minerals. Here's your residue in soybeans and wheat. Your opportunity is to get those to the next year's crop. So this is a picture from the day we took that video. The video was done in August. That application in December in Wisconsin was done months prior. But here's where the residue pass was made. Here's where it wasn't. So the process of getting the minerals from that corn stover is shown here in the next season's crop. The Greek word for change is metabolize. We know, if you think back to one of the first slides, nitrite to nitrate, peptide, amino to protein, that's all a step, a change. You talk about secondary metabolites, you talk about change, minerals, microbes, and a catalyst does this. So sugars, proteins, enzymes, amino acids, what you really want to have is a really broad and balanced base of minerals and a really diverse population of biology, both fungal and bacterial, and you can accomplish this. Exchange minerals from one to the next. We talked a little bit about, nice job on the fungal highway earlier. Literally these microbes, different groups all together, are taking that mineral molecule, running up and down the hyphae, taking the mineral to the plant and coming back with a hydrated molecule. Solubilize, again, one of my We talked about one of my favorite authors, David Montgomery. He's a geologist. The link between geology and biology is fertilizer. What does that mean? That there's soil particles that are in the rock form essentially, not available to the plant. The microbes that do the solubilization can take those, make them small enough to create uptake. What you're seeing here is take a Haney test, put down our product, wait 8 weeks and take a Haney test again, and there's a 90-pound increase in phosphorus. So that's a pretty impressive number. If where we live, there is boatloads of phosphorus in the soil, you just can't get it. Consume pathogens, again, these are just to highlight the number of different species doing different functions. This is
the fungicides, maybe 7-8 years ago, we were putting fungicide on everything, on our first spray to kill this and that. And it seemed to work okay for the first year or two. But then after that, our yields started going down, mainly because of this white mold issue we've had. Mm-hmm. And when you go from having, 50, 60 bushel beans and white mold comes in, it goes down to 10 to 20.
Right.
And you can't have that. And I think originally it started to help, but now we're having an adverse effect.
You felt it.
Yes.
Just killed a lot of the things.
It killed all the beneficials, right. It just sterilized the soil. Corn soybean rotation. And then we move ahead to 17, where we're using them pretty heavy now. I think that was maybe the last year of it. And you can see on this 40 up in the corner, the white mold started to devastate it. You move ahead 2 years forward in 19, before we were actually using the sugars and the CX1, and it completely wiped the field out. And then now as we move into last year, it would have had CX1 and the sugar on the corn, and now this year on the soybeans, and there's literally no white mold out there, and I'm guessing it's going to be 15 to 20 bushel more.
Nice. You've gone, I think you I asked about check strips, and you said, no, not this year. It's on all your acres, all your crops.
Yep.
So I think really the most important statement in there is that the unintended consequences of some of the other things they were doing sterilize the soil, right? We, in our body, our body's filled with salmonella, E. coli, listeria, but we don't walk around sick because we have this balance of good and bad. And the fact is that if you take away the good in your soil, then your plants become more susceptible to pathogens and diseases. So this is a product that allows you to re-inoculate with good biology. The mode of action we're talking about here is biosanitation, where the good guys actually eat the bad guys. So the white mold is consumed by the gram-positive bacteria. Slightly different is competitive exclusion. And what you see here, this is in Arizona, high-powered microscope of a pea root, and you see this line of biological defense. That's biology protecting that plant. Without our product, you can see how exposed and vulnerable the pea root is. With it, again, that's that biological line of defense. How they run these trials is without the purple cow, you plant the pea in these specialized sacks, you inject the pathogen here, and the peas become diseased. With the inoculant, you do the same thing, but when you inject the pathogen, in this case, the peas do not become diseased because here you have that biological line of defense you can't see. So that is competitive exclusion. Biology fends the pathogen away versus biosanitation. Finally, building carbon. Here are the scientific types of carbon. What I find that people can really resonate, what can really resonate with growers especially, is you have green carbon, that's what's growing. You have brown carbon, which is essentially your residue, and then you have black carbon. And your opportunity to take that plant material through from green to brown to black allows you to build soil carbon. These are the 4 steps. What's interesting is as the plant is taking about half of its energy and exuding those minerals into the soil, bacteria can consume the sugars, but it takes fungi to consume the oils and lipids that are really building your soil carbon, right? If you don't have the fungi there, this is why you want the feedstock is a balance of bacteria and fungi. If you don't have the fungi there, those oil and lipids, which are potentially soil carbon, will oxidize back in the atmosphere. So selecting a biological that gives you the best chance for success. A whole bunch of products out there. I mean, I think the $64,000 question in the mind of growers today is, which one do I choose? When Ohio State hosted an industry panel of experts, that question was asked of them. This is their answer in order of importance. Choose a product that has the most diversity. Interestingly enough, there was a gentleman in the audience Tuesday. He never heard this part of it. He's used biologicals. They've never worked. I mean, he never used really a food source with them. Biologicals need a food source. They can find food in the soil with a root exudate, but to have a food source in your tank before you go, you get that activity a lot quicker. So this panel of experts acknowledge that. This is really about buying from somebody you trust, somebody that you can get a consistent product, batch in and batch out. This is an industry term for using more than one product together. You can certainly do that. I mean, there's nothing about any of the other products here that wouldn't, tank partner well with Liquilife. And then this is largely about carbon to nitrogen ratios and the interfacing of the plant and the soil. And so these are the most in order. Choose diversity, and I would add balance, meaning balance of bacteria to fungi. Use with a food source, consistency. So to take a minute and kind of help just identify what other products in the market look like or what they are. A lot of biologicals are a byproduct of biology. Many of the products are food for biology. So they're a biostimulant, molasses, sugars. None of these are bad. They're all needed, but just to differentiate products. And a lot of them are limited species biologicals. So these are the common limited species biologicals that we run into in the Midwest. I'm sure that there are others here, but the point is this is a biostimulant, this is 2 species, this is 1, 2, 1, and Liquilife and Liquilife Plus are a broad spectrum, meaning you're getting literally a couple thousand species of bacteria and a couple thousand species of fungi, and we just feel like that diversity and balance is going to give you a better chance to succeed. I use this product as an example. This is a metho that can fix nitrogen from the leaf surfaces. If you read some of their material, they'll say they're the only product on the market that can bring you a metho. If you go through the DNA sequencing, these are the methos that would be in our product. So it's because of the way it's made, naturally taking microbes from real culture media, carbon, and soil, we're able to provide this product that has a lot more species and a good balance between fungi and bacteria. This is a fact. The products that are, that you're going to hear about later today don't fall into this category. They're made a little differently, but this is just a science fact. If these are the species the guys from Cornell came up with that were in a batch of the Liquilife, this would run for 8.5 minutes. If we showed the whole thing, it's like 15 seconds worth of stuff. Those guys at Cornell, they don't know what they all do. You talked about it. You need this microbe, but you need this microbe to support it. So it's a whole world that we're just beginning to understand. And guys like Mark are helping to bring some knowledge to the industry. But our position is biology is good. Find a diverse and balanced product and use it in your system. So in the nitrogen conversation, biological diversity matters. It matters because you're getting nitrogen from the atmosphere, you're getting nitrogen from the soil. Every 1% of organic matter is 2,000 pounds of nitrogen. If biologically, you can get it. You have nitrogen that's applied, you have nitrogen from residue. So you see the balance, you see the benefit of a broad spectrum. We talked a little bit about carbon and minerals and biology together. There's 2 ends of the fertilizer spectrum. On the one side, you have these highly available, more likely to leach inputs. So what you want to do is you want to add carbon first to immobilize them, make sure they're there when the plant's most likely to need it, and then the biology drives the train, drives the bus. So carbon with a highly soluble, think UAN, is about immobilizing it so that it doesn't leach away, and then biology can metabolize it into, and we'll get into a little later how an amino nitrogen is better than a nitrate nitrogen, but biology metabolizes, from one stage to the next. When inputs are not readily available, there's a couple of reasons for it. We'll go over it. But this is, think about back to microbes digest carbon. When your minerals are tied up, biology first to liberate them, the carbon then to hold them, and hopefully, we'll talk about it as salt in terms of a salt molecule. But then once they're held a little differently with more energy, biology can again drive the exchange. So this is the slide that I have in my presentation, just to talk about the importance of the physical part of the soil, the chemical, which is the fertilizer part of the soil, and the biological part of the soil. This is kind of a feel-good word. This is what's really important to growers. This is, kind of what pays the bills. Different people have different, interests here. This is a real big, driving motivation for me. But when you can get a system to be more productive, that's really when you're going to see the gains. I have this slide in here just to reinforce we're not just talking about NPK when we talk about minerals. We're talking about a lot of other things. Again, this slide to illustrate how many minerals can come from residue, that you've already paid and grown. This is an even more extreme documentation. This is a really nice 7-way blend. If you're doing cover crops in a 7-way blend, these are the minerals that you've grown, just the above ground minerals, not even to speak of what's below ground. And again, these are in that cover crop in the green stage. If you can get them to brown and to black, then you can gain the benefit of that from a really, really good cover crop. So, if you're buying phosphorus and you're getting, say, 10%, then that means that for every dollar you spend, you're getting 10 cents back. This is kind of depicts the, if you've ever heard somebody say, I used to put this on and I used to get this, and now I'm putting that same amount on and I'm just not getting the return. This depicts that challenge with getting less out of your applied fertilizer than you've gotten in the past. The double whammy is you're having to pay more for it and you're having to use more for it. So this ultimately is the reason why better quality inputs attach every mineral molecule to a carbon particle can be really the key to yield, to fertility efficiency, to nutrient density, and to plant health.
On that last slide, it shows decreasing uptake efficiency over time.
Yeah.
Is that correlating it to poor biology due to poor soil health practices over time?
I'm glad you asked. Yes, I would say yes. A couple of my next slides are specifically to address that. Assuming there's moisture, got to have moisture. If you're not getting your minerals to the plant, it's either a chemistry or a biological challenge, right? I don't know. I've said this before. No one said it's something else, so I'm going to go as that as being true. Minerals tied up, and I think this is part of what you're asking. And again, I'll go back to the chelation effect of some of the products that you're using. And again, we've been guided and directed to use some of these products, but a chelator ties up minerals in a way that they're just not available to the plant. And when you have them tied up with less biology, that's why you're not getting them. Yeah.
We'll expand on that later with different chelating items and how the bonds are so strong in efficiencies.
I have this testimonial here just to highlight this point. And I have it because this guy's a research specialist at a big university, right? He knows everything he needs to know about a soil test, but they still weren't getting those minerals to the plant. Biology, and you can see that he alleviated that challenge. we see this all the time. You can have a gem up, perfect soil test, and your plant's not getting something, right? Or you can have a wonky soil test, but the plant's still getting what it needs. So that's the role of biology and availability in all of this. We know that trouble can be had with a deficiency as easily as it can be had with an excess. When you talk about balancing your minerals, this could be one of the reasons why. Again, that's a chemistry imbalance. This could be one of the reasons why your plant's not getting your minerals. And then this is, I think, one of the real key things to keep in mind here. So a salt molecule is essentially a molecule that all the exchange sites are full, and there's an equal number of plus and minuses, right? Anions and ions. What does that mean about that molecule?
Stable.
It's stable. It has no exchange capacity. It has no energy. It just sits there. Yeah, that's the problem with the salt molecule. There's a way to fix it with chemistry. There's a way to fix it with biology. If you attack it from both sides, it's even better. You can first cause disassociation with biology. Break up that molecule. When we talk about the microbes that consume salts, that's what we're talking about here. You reassociate it with carbon. So you reassociate it in a way that it's structured differently. There's available exchange sites, whether they're positives or negatives. It brings energy back into that molecule, and then you drive the exchange with biology. This is a biological fix. Calcium is a chemical fix. What do we know about, they call calcium the trucker of all minerals. Why do they call calcium the trucker of all minerals? Because it has so many available exchange sites that other minerals can just tag along and be taken up to the plant, right? So calcium with its available sites can work from a chemistry standpoint. Biology has a fix on the biological side. So when you attack them both, here's an example of this. This is strawberries in Florida, fish fertilizer, high salt, designed to be a fertilizer, right? Ends up that it becomes a limiting factor because there's this salt layer, right? Use biology and carbon here. These bags, they just kind of cut this away to expose this. Once they put the biology and carbon in, what we think you're seeing here is biology is breaking that up. The carbon is reassociating it. Now, that salt layer that was a limiting factor has gone back to be a positive, fertilizer input, and then you can see the difference in the roots. As a general guideline, again, you've heard me say this. I'll go to when you attach every mineral molecule to a carbon particle and drive the exchange with biology, you can have an efficacy equivalency of about 60 to 70%. Really general, but if you're using 100 units of something, and you find a way to add carbon and biology to that mix, you can use 60 to 70 units and get an equal response. Guideline, general guideline. It's going to be a little different based on, and then this is what I said before. Use better quality inputs, place them with precision, apply them more frequently. This is part of the reason drone technology is going to be a game changer for our industry. When you compare minerals through the roots versus minerals through the tissue, this particular study showed potassium 8 times more efficient. Here are the other inputs in that trial. Boron, phos, nitrogen, you could just see. The real kicker here is that you can be more nimble in your operation. I mean, there are growers that sit down in January and decide what they're going to do in July, right? And when they do that, they have to make sure they put enough of this on so they don't run out. You can start at a lower level and then observe what you may or may not need based on what you do or don't see, and you can come back with a foliar application. These are important notes for making a foliar application: temperature, time of day. Try to avoid extended periods of drought because it's just not going to work. I will say a little bit about silica. I learned a little bit about silica this morning. the carbon particle in our the Liquid Life Plus so small that on the leaf surfaces, minerals can be taken up through the process of endocytosis, where the minerals actually enveloped in the plant versus diffusion or osmosis. I know that's a little sciencey, but this is the reason why you can, with small silica particles and fertilizer and biology together, have a lot of success with a foliar. I'll pause for a second. Any questions? That's the first two sections of what I wanted to talk about today. And then I'll get into just the final section, which is tank partners, and hopefully I've got some crops loaded up here that you are interested in growing. Anything? All right. So I like to acknowledge that there's three different mindsets to farming. One of our most successful dealers is he's the no-till, non-irrigated corn growing champ of the world. The last thing he wants to, not of the world, of the United States, the last thing he wants to hear is, I'm going to use less fertilizer, right? I would put him in the category of the max yielders. What they want to do is they want to bring carbon and biology into their system to push the envelope. I would say this is the grower we deal most with. I call them the moderate gainers. That 60 to 70% rate of fertilizer with carbon and biology. I mean, we've seen this, and you'll see it. I've got a section on nitrogen efficiency, but more corn, better corn. By that I mean sugars and starches, nutrient density, and more profitable corn. This can be done. And then there are some low input farmers, and they just want to, they want to try to get what they can from what they grow and what's in their soil. Really the good news for us is biology is their friend, no matter which category they're in. You can use this, anywhere. It's a liquid. It has the viscosity of water and the weight of water, so it can go in pivots, planes, drones. A lot of times the strategy is going to be to use it in lieu of some chemical application in your system. The greatest example of this is and the important thing is you have to have the rest of your fertility program in solid. You can't do it in lieu of fertility if you don't have fertility someplace else. But if you have like a precision planting piece of equipment, you can put biology in a food source right on the seed, have your 2x2 filled with the nutrients that you need. That biology will give the seed, along with what's in the soil, what it needs to get started, and then your fertility kicks in. Or you can use it in conjunction with, and this is the strategy where, cut back a little bit, use carbon and biology. So just want to make a distinction between the in lieu of strategy, your fertility program has to be solid, and then in conjunction with. I do have a bit on nitrogen, so we'll go over this there. I never start the conversation with any grower about really cutting back on their nitrogen because that just makes growers uncomfortable. I would never say to somebody start with a 40% reduction of your nitrogen. I start the nitrogen conversation here 80-10-10. If you were using 30 gallons of UAN, 80% of that is 24, 3 gallons of a liquid carbon, 3 gallons of biology. That is an inclusion strategy that for the most part is the same number of gallons. For the most part, it's pretty cost neutral. And that's a better blend because you're immobilizing that nitrogen, biology is metabolizing that nitrogen into an amino form. So talking about Tuesday, the advantage of an amino nitrogen versus a nitrate nitrogen, when you plant takes up a nitrate nitrogen, it has to do the work to convert it to an amino form, right? So what that means is the plant diverts its energy to that conversion of nitrogen. When you use an amino nitrogen, the plant doesn't have to use that energy to do just that. So we talk about better quality inputs. That's what we're talking about. You heard me talk about this. You heard me talk about this. I would make the case that, like fertilizer, split applications with biology is a good idea. I would rather have you use 2 gallons of the Liquid Life at 3 different application points rather than 6 gallons all at once. The 3 key and general touch points would be on or as close to the seed as possible. Sometimes this is an early foliar. Second would be an early foliar, again, with the food source, carbon and fertility. And the third would be a residue pass or a late foliar. The other point to keep in mind, and you're all going to know this about your crops much better than me, you have critical growth stages for each crop. And that's the time when if you can get your minerals and your carbon and biology to that plant, to that crop, 7 to 10 days prior, it's going to get through that critical growth stage with less stress, and less stress means good things. Tank partners. So we've already talked about the sides. They can be chelators and detrimental. It's best if you use Liquilife independent of these, but if you can't now, you have a parallel operation, right? Are you all organic?
All organic.
You're all organic. All organic and all organic.
Conventional.
You're conventional, okay. So you can see, liquid carbon is good to have in the mix if you're going to use it with some of these. I've got some good corn programs on a conventional in my nitrogen section. Try to avoid it with the fungicides. There are some biologically friendly fungicides. Demise is what I would call a very biologically friendly fungicides. If you've got a harsh fungicide, what you really want to do, beets, potatoes, ginseng is maybe the worst. Clean up the neighborhood, so to speak, and then bring in the beneficial microbes after that. We've had bait growers that have been able to take, for instance, a program that might be 7 or 8 fungicide passes and reduce it down to 3 by extending the duration of time between applications. We're going to talk about the nitrogen efficiency conversation. It's never going to be registered as a fungicide. The goal here is to promote the health of the plant. We're going to see this in the alfalfa section. But the other thing that I will say is we're not talking to farmers about not using the tools that are in your toolbox. That's a phrase that everybody, I think, understands. What we're talking about is using those tools better, taking it 2 steps plus forward with biology, and then if you have to set it back a little bit, 1 step, you're still making that progress rather than, use a biological, take 1 step forward, and then take 2 steps back, because it's really about return on investment this year and then inching your way to a better system. All right, so these are the things that we need to do in your operation. These need to result in return on your investment. And if we can do that this year and improve your system, then we're on a path together. So let's look at corn. I know you're a corn grower. I usually start with corn because just about everybody in the room is a corn grower. Here are the general rules. Here are the critical growth stages. So you probably know the statistics on corn. Out of the ground 3 days late is a 25% reduction in yield. 3 more days late is another 25% reduction in yield. And for many, they feel like out of the ground 6 days after the first come out is going to take from your overall yield, not add to it. They should be treated like a weed. Those are not my statistics. Those are published. But it's highlighting the importance of germination and emergence. V5, what's happening at V5? At V5, very early in the corn growing stage, is when you're determining the number of kernel rows. People think it's way later than that. It's that early. And then V11 to tassel is largely about tip fill. So pretty picture, pretty picture, pretty picture. You've seen those before. The thing that I'm trying to point out here is that when, the weather gets challenging, this root's going to mine for minerals and moisture better than that root. Very interesting unintended study. What happened here is this grower in Wisconsin, there's a lot of small acre fields. So if a guy's got a lot of acres, he's got it in many different places. Late at night, he had no tools. He had precision planting, but his in-furrow was not working properly. He completely forgot about it. His in-furrow, what we're really talking about here, is 1.5 gallons of the liquid life and then a pint of seaweed extract, okay? The difference here is pretty remarkable. He had a really solid fertility program, 2x2, so where his equipment messed up, this is all that didn't get, all right? Like I said, he blamed it on his manure applicator because he thought these streaks in the field were something different. Then he got there to harvest as a silage corn, and he realized these streaks are in 16-inch rows. There's something else going on here. He realized that this is where, and the 16 goes this way, this is where the equipment was working, and this is where it wasn't. So he hopped off. He cut some stalks, he broke some of the ears, where this is simply 1.5 gallons of biology and a little kelp. It was 12 rows by 40 kernels, whereas where he was working properly, he was 16 by 43. Again, stand count is about germination and emergence. Consistency in size, look at how inconsistent this is, right? Versus this, that's about getting out of the ground quickly. And then you see tip fill. This is all a result of just a single in-furrow application. Whenever you see a slide in the presentation more than once, I'm trying to highlight a different value proposition to the grower. Here we're talking about the corn that was planted with biology had 15% more protein, 7% more methionine. Remember, these are the secondary metabolites we talked about earlier where biology and minerals can do this for you. So proteins, vitamins, enzymes, amino acids. This is when you have your biological system working well and you have all the minerals you need, and then you have a catalyst, which is oftentimes a biological excretion or secretion, which is just microbes pooping or sweating, right? That's what can happen. You're going to see Josh a couple times in today's presentation. This is a note on fertility efficiency because I get a lot of times I don't get paid for nutrient density, right? Really good success story. Adding biology from Purple Cow, this, and this. Here is how he's got paid for his nutrient density, right? He went from 18 pounds a day to 12 to 15 pounds a day because he was growing better corn. So what that meant was his forage acres, he could cut by 33% and dedicate those acres to cash crops. We talked about if you didn't have liquid on your planter, very interesting testimony because this is a pretty high profile organization in Wisconsin. You might have heard of Organic Valley. Zach did this test one year. He was uncomfortable putting his name to it, so he did it the next year, pointing out here simply that he planted on the 6th. The application was done 2 weeks later. When we talk about biology getting the most out of your dry fertilizer, in other words, microbes, biology consumes carbon and liberates the minerals from it. Poultry litter would be what we're really working on here. You can see moisture, test weight, bushels, dollars. This is another example of granular down throughout the field. Biology on top of that granular at a very early V stage. You got 18 rows here versus 16 rows here. Rows come in pairs, 10 bushels per row, so there's a 20 bushel. This is not the actual factual. This is the estimated based on if the weather does this throughout the year. This is high tech, at the time that this was taken. But the point is you've gotten, additional rows, probably because you got more out of your fertilizer in the right time. Tip fill. Any wheat growers here? All right, so wheat, what I would say, are you planting winter wheat? Spring wheat, okay. So this really depends on the type of wheat. I have mostly information on winter wheat in this slide, but I think the messages still are pertinent. I'd do 3 times at these touch points. If you didn't have liquid on your planter, I'd up the rate and do 2. So some really interesting pictures from Kansas this year. This is with the biology. This is without. This is a plant health and system resiliency slide. So we know that a more turgid plant will help prevent pests, right? We know that a plant that produces complex carbohydrates can help in terms of insect prevention, because the insects without a pancreas can't digest the healthier plants. They'll go elsewhere. And here is a really cool example of how Brix levels have helped this farmer. So this is winter wheat. The application was made when it came out of spring dormancy, out of winter dormancy, spring green up, okay? We took these pictures, and they were very much like this. You know, you're looking at all the good things that you easily see. We didn't see until we got back to the office, and I'm going to highlight is right here. This is our belief. The application in the early spring created productivity to the point that you increased the Brix levels, and the sugars in this case acted as an antifreeze. They had some nights where the temperature dipped down below freezing. It didn't seem to affect this side of the field like it affected that side.
The research shows if you have 12 Brix in wheat, you're good to 22 degrees.
Okay, there you go. Really, that's...
It took me a long time to find that research, but I found a paper that they were correlating Brix value to freeze prevention.
We hear it a lot in orchards and vineyards. They'll do that. They'll try to get that plant going to, fill the plant with antifreeze for overnight frost. 22 degrees that's significant.
Yeah.
So, I mean, ever kind of understand what he said? Do you follow Brix?
We try to.
Yeah, it's really like it's got to be same time of the day, same. I mean, it's really hard to.
It should be at peak photosynthesis is when you should check it. What I used to say, it's made by Milwaukee. It's not the Milwaukee. It's another company, Milwaukee Instruments, but it's an electronic Brix. And so you just put it, there's a little sensor, you drop your plant fluid on there, hit a button, and it gives you the number. You don't have to look through the stupid little thing. They're about $120 and they're worth every penny of it.
So what you do is you take some of the leaves and you crush out the juice, and then you put it in a refractometer, right? And it gives you a reading of the protein and the sugar and the nutrient density. And the belief is that if you can get your Brix levels high enough, that every crop has a point at which you'll get insect protection, and the temperature protection comes from the higher sugars. But Brix is protein. It's really it's interesting, but I find it to be like soil tests, right? Soil tests should be a trend line analysis. That's not the Bible of what's really happening in your soil, but following it, if you go ahead.
There's a presentation by Thomas Dykstra. It's on YouTube. He's an entomologist out of Florida that actually shows what insects will stop feeding at what Brix level.
Yeah.
And then it also corresponds it to nutrition in the grain or the fruit or whatever. And also, in addition to cut off on insects, about between 10 and 12, the only insect that will eat on it is grasshopper, and pretty much all your disease issues go away.
Yeah.
So Brix is huge if you start following it.
Yeah, so when we talk about Brix, it's the same conversation as nutrient density. And so this prevents the pathogens, this prevents the insects. This is the example of, frost. So, yeah, I always like doing a presentation and having a Brix follower in the room because, some people, it really reinforces what we're trying to do here. So I love this. This is winter wheat, but I love this picture because you take a peek at it and you think, wow, there's just so many more plants here than here. But that's really not the case. I think there might be one or two more, but what you're seeing here are the tillers. And this is a gallon. This would be 2 gallons of Liquilife. The nano-enhanced biological, you use half the rate as the Liquilife. So 2 gallons of Liquilife, 2 gallons of a molasses fertilizer, 4 ounces of zinc, 20 days after planting. So look at the tillers and look at the root development. This can be the difference between making it through a winter or not. We see this in alfalfa too.
So is this foliar or streamed on?
You know what they say in Kansas? He put it right in the slice. So, so he did it at planting. I'm not sure exactly where he puts it when he puts it in the slice. I should ask him because you're the first person I just got this not that long ago. But in Kansas, they call about, I think they're talking about right on the seed, but they refer to it as the slice. It's not foliar. Other fields, again, this is 20 days. I mentioned this guy's name before. He's the U.S. corn champ. He's also, he's got some customers that are in wheat competition growing. This is his neighbors where he did side by side at planting, easily 40 bushel difference. They averaged about 120, I think, in the whole field, but he was up to close to 200 in some of the areas where he used the biology. This is here in Nebraska. There in Nebraska, sorry, we're in Colorado today, where one of Kyle's customers, better yielding, lower cost, higher price. Alfalfa, you grow alfalfa? Do you? Okay, cool. Again, the best time to use it is after first and second cuttings. First job is to heal the wound. Second job to get the plant back into production as soon as possible. You can achieve greater yields, higher increases in quality, shorter cutting season. If it's a new crop, I would do it at planting or spring green-up. So different application strategies depending on how many years your alfalfa's been growing.
Is this sprayed on or what, ground rig application? Or
Yeah, so right after first and second cuttings is where you'd come over the top and spray it on. And by doing that, you use biology and minerals and carbon. If it's organic, you've got some great products that would go with the biology. Yeah, we should talk about that because their products are, you want a food source, you want carbon, you want minerals. They would go together great. So right after first cutting, you have to do the work in the field and then heal the wound, get it back into productivity. And then after second cutting, that's for an established crop.
So applying this on a hail crop.
Hail? Yeah, I got a picture. In Kansas this year, we had so much hail, and I've got a side-by-side from the hail field. So what happens is, you get hail, and the farmer automatically goes to a fungicide, right? And what you're doing is you're setting back the production on the crop. This is where, it's dangerous to make this analogy, but the difference between chemotherapy and immunotherapy, we're seeing this in medicine. Instead of coming in and killing everything with a fungicide, just try to support the health and growth. And you can get that crop back into production. So we had so many cases with hail this year in Kansas that the growers did a side-by-side, and it was night and day different. They didn't need the fungicide. What they needed was to get the crop growing again. So I have this is a sod farm testimonial, but it's in the alfalfa just because in Florida, you cut the ribbons and then you need to get it back into production, just like alfalfa. So on the same number of acres, the sod is sold in square feet, right? On the same number of acres, they went from 2.6 million feet of production to almost 5 million. Essentially, that's a $760,000 increase. Getting 3 crops in 2 years on the St. Augustine, 2 cycles of Bermuda. So this is the same thing we're talking about in alfalfa. You cut it, and then you get it going again. Love this picture because we talk about getting paid for different things. Clear to see you're going to get paid here for 43% heavier alfalfa. That's the solid stems versus the hollow stems. That's the sugars, that's the starches, that's more milk, higher constituents, improved animal health. You might not get paid for this, but it's real. You get paid for the weight. You get paid for the aminos and the vitamins. The really good part of this, now we're talking about plant health, return on investment today, and a system improvement in the years to come. So in 2020 is when this was taken. 4 good cuttings, and then a plow down. I was at a field this year in North Dakota. The guy was on his 3rd cutting. He needed 4. He planted an alfalfa that he needed for 4 cuttings for his farm. After this 1st and 2nd cutting, he had all that he needed. So his neighbor's trucks were in his field on his 3rd cutting that day we were there. He said, I've never had this before. So this is nutrient density and yield, giving him two cuttings that he's selling to his neighbor. Anyways, in 2021, it went to a small grain. In 2022, it went to corn. 2 years later, there was 20 to 30 more bushels on this side. Is that the microbe that we applied 2 years prior? No, it's not. Go ahead.
Would you see some of the same effect, whether like spray and chemicate, like putting it through a sprinkler?
Oh yeah, you can put it through the sprinkler. Yep, spray, streamer, pivot, drone, airplane. Yeah, how you get it now. The further from the target, you might need more volume. That's where if you precisely place it, you can cut your rates. So the further you get, in the sky, pivots are pretty good. They're pretty close. But if you're going, helicopter, then you have to put more on. So
The effectiveness of drone coverage versus helicopter or plane, are you guys seeing better with the drone?
we have customers using it in drones. I don't have. It's just so new that we don't really have a. I don't think I could find any comparative data of a helicopter, so I don't think I'll ever be able to give you that. Quite honestly, there was 4 years ago where there was this big cannabis boom. That's when we had most of the helicopters, but that's not here anymore. So, my point here, it's not the microbes that made this difference. It's 2 things. I'm showing this slide about the benefits of the minerals that we're growing, right? These are minerals that are grown in a cover crop. Same thing is applied to the minerals that's grown in alfalfa. When you plowed that better alfalfa down, you got more minerals. The other thing you got, it's really bad English. The other thing you have is better sugars and starches and microbial food. So you get this system going. We talk about ROI this year, get your system going. I like this video.
Not sure how well you can see this, but this was sprayed in 2022 with 5 gallons of Boost and 5 gallons of CX1 after first cutting. Then right here is the spray line, and then to the left side was not sprayed. Last year we saw significant increase in weight of the sprayed versus non-sprayed, and a year later you can still see the line in the field, which is right there. This was sprayed.
I'm in my office. It's May of this year. The only reason that guy's in that field is to see if he can make first cutting for 2023. And he called me and goes, Steve, I'm out here. Is it possible that I can still see that line from the year prior? And I said, take a picture and send it to me. And he did a really nice job at narrating the video. But again, ROI the first year, system improvement for the year to come.
Did they look at nitrogen fixation with application and without?
They didn't look at that. I mean, again, that's sometimes the best trials are the ones that you don't intend to be a trial. There was no intention for that to be a trial other than the side-by-side that first year. Interesting on that field, though, when we went up to look at it the year prior, you really couldn't see that much difference. And the consultant says, I challenge you to find the difference, because from the road, they look the same. The value came in the weight and the relative feed quality. But when we got in the field, you could see the leaf hoppers on the non-treated side. So you could, the guy I was with said, "Oh, of course, here's the not treated side," and it was yeah, pretty. No legume growers in the room. You're a legume grower. How much time do I have?
You can skip legumes.
All right, I'll just go. Here,
Alfalfa's a legume.
yes, that's true. Here's the critical growth stages for legumes. Pathogens, it's one thing to set a lot of pods. It's a completely different to fill them. For legumes, I think the foliar applications are more important than everything. You set a lot of pods and you run out of groceries, all you got is a lot of empty pods. University of Wisconsin, nodulation trials, pretty pictures, a reminder of how important timing is with foliars, and then just a reminder, sudden death is more of a competitive exclusion. White mold is a biosanitation. So you're doing, this is through the root, this is through the surface. This is, I think, the last thing I'm going to cover today, and then I want to make sure I'm not taking up everybody's time. How important is this topic to you? I mean, do you track this? Who tracks nitrogen per bushel? You do? What are you running?
I'm running half a pound on corn. I'm very efficient with my nitrogen.
You're good. That's I usually get 0.6
Per bushel?
Yeah. You're gonna like this. I should get you and Josh together. All right. So these are the recommendations. We firmly believe this. We firmly believe that's redundant. We've done years of trials on this. So this is control at 0.82. This is control at 0.66. Anytime we're above, this is third-party research. Anytime we're above 6, it's more corn, better corn. When we get down here, we saw negative to the grower. All right. Remember this story? Josh went from 10,000 gallons to 3,500 gallons, adding biology.
When we were in the field, you made a remarkable statement to me. You've been a long time user of 28% UAN.
Yeah.
And 700 acres. You've in the past used how many gallons of UAN, and what are you looking forward to next year?
I think recently, the last few years, we've been growing probably 400 acres of corn.
Yeah.
And when we started, we were using 10,000 gallons an acre, which is
10,000 gallons on a farm.
or 10,000 gallons on 400 acres,
Yeah,
which is
there you
about
go.
25 gallons an acre.
Yeah.
And now we're down to about 10.
Yeah.
I mean, that's what we've got purchased for 2023's acreage is about 9 to 10 gallons an acre.
And you really believe that your farm can go from a 10,000 gallon of UAN a year to 3,500 gallons of UAN?
Yeah, I mean, are we gonna increase yield in that amount? No, but so far this year, we've pretty much maintained a 200 bushel average on what we used last year, which was about 14 gallons of UAN. And so are we getting 300 bushel? No, but I'm not spending a whole lot to get 200.
Right.
And so that's always kind of my philosophy is, while I want the highest yields, I'd rather have the highest profit.
Sure.
So this was done before the 2023 season, and he was talking about maintaining his 200s. So he uses, this year in 2023, after the video was done, he planted with 3 different protocols. All of his corn got 2 gallons of Liquid Life, 2 gallons of, this is a liquid carbon. Again, this would be a product you could get here. 10 gallons of 32%, and then he credits 70 units of nitrogen from his spring applied manure. So this is minerals, carbon biology, and 103 units of nitrogen. Protocol A, in addition to this, was 4 gallons of CX1, 5 gallons of an amino nitrogen. So this totals 113. That's the total between this and the extra. Protocol B, in addition to this 103, there were 12 gallons of 32 Y dropped at V8. So that totals 143. And then protocol C was just this no second pass, okay? Biology and aminos, he was at 250 on 113 units of applied nitrogen. Remember, 70 of that is from the manure. That's a 0.45. With the UAN, he had 1.7 bushels more, but it took him 30 extra units of nitrogen to get there. That's 0.57. And his starter only, 244, he's a 0.42. So kudos to you, because I've never been in an audience or asked and people said, I know my number and it's below 5. But it can be done. This is his best margin. This is his best contribution, meaning he's taking more money to the bank here. This is the percentage leader. Here's his soybean program. Wasn't a good year for precipitation soybeans, but he was pretty happy. His soybean program is 2 gallons of Liquid Life, 2 gallons of Boost, with his pre-herbicide pass, 4 gallons of biology, 4 gallons of liquid carbon with his post-herbicide pass. He's using Ledger. He's uses glyphosate if he's burning rye, and then his post-herbicide pass you can see there. Felt like he got a 4-to-1 return on investment with biology on his legumes. Clearly, this was a 2022 organic corn study. We really did well in this study. There were 9 treatments that had liquid nitrogen only. Here's when 9 treatments that had liquid nitrogen. When you used it alone, when you used it with carbon, when you used it with the broad spectrum biological. You can see the return on investment numbers. I will take, you know what, I don't need to take anyone through this. You've seen this, you've got it mastered, and you're not doing conventional. All right, I don't need to go through this. You don't need beets, residues, specialty crop. I think I can wrap it up right there. Thanks for your time. I know that's a little longer than I probably should have gone, but I love it when there's questions in the room. That means somebody's engaged.
I want to comment something on specialty crops. We grow a lot of specialty crops. And we just acquired a 300-acre farm from a different farmer that we're taking that over. And he hasn't been using much of anything other than sometimes he puts on cow manure. And we've been doing this 3 years now. And his kales, I mean, we mainly grow kales, cabbage, all the brassicas.
Yeah.
So one example was his green kales, his lacinato kale, stopped growing at like 22 inches when it got really hot. And we couldn't harvest that no more. Our kales and brassicas just kept on growing with less bug pressure than his.
Yeah.
And we finished our kales at 63 inches tall, and his stayed at 24.
Yeah.
So we can go with kales anywhere, we can go with corn anywhere. And so now we're having to fix this 300-acre farm.
Yeah.
That, we want it to be productive, but we have a lot of work to do on it. So.
Yeah, I'm going to guess it's either a chelator from the manure can be a chelator or the other minerals, or it's biology. How long have you been farming it?
This was our first year.
Yeah. Might take you a little while.
It's going to take a little while.
Yeah.
But his biology, there is no biology. There is no, we just have so much improvement to do on this.
Yeah. Yeah.
So.
And that's going to be a function of time and budget, right? I mean, you got to figure that out, what you can afford and how much time you want to take to fix that. But kudos to you for taking it on. Yeah. I know you run a good operation.
How is manure chelator?
That's an interesting question. The studies have been done. There's a full application level of glyphosate in a manure application.
Say that again.
There's a full application level of glyphosate in a manure application.
Well,
Yeah.
is that what you're saying?
Yeah, because of what the cow's eating. It's what your food ate. So unbeknownst to a lot of people, organic, guys that are using organic poultry litter, I mean, they don't really think about this, but it's a fact.
But if you have good biology, there's a certain family of bacteria that actually consume glyphosate. It'll free that up. The key is you have to have good biology.
Right, and a lot of the organic guys can do that. But when you look at the trend lines of why you're not getting some from your soil on the conventional side, they don't have that protection. Yeah.
Very good, Steve. Thank you.
Thank you.
Want to comment a little bit on Roy's nitrogen use efficiency. I've got some growers right by our Nebraska store that are biologically minded conventional growers just like Roy. I think 2 years ago now was the time that we passed the threshold, got below 0.6 of a unit of N per bushel of corn. That is still continually dropping. The product Steve mentioned and what we've mentioned so far today, these conventional growers have incorporated this into their program, and their soil health is so much better and crop health is so much better that it's amazing the amount of inputs we have dropped. Now, I can't say the costs have gone clear down because we have traded inputs, but our efficiency of what we're using and the residues that are left in the soil that can be harmful, our salt levels going down, it's just an amazing transformation. You know?
Yeah.
We deal mostly with organic, but we do have some biologically minded conventional growers that are just throttling their peers.
Yeah. I mean, when we started, we were 95%, organic customers. But now it is that section of the industry that the biologically minded conventional grower. They've done a lot of other things and they've got to this point, and I think we can help them faster in some cases because they really need that biology to reverse the trend.
Have you seen with your lower nitrogen applications, your weed pressures going down on those weeds that are such high consumers of nitrogen?
What we're seeing on our weeds is where it runs in off the neighbors. That's where our worst weeds are. So that's telling me when the neighbors are running off rainwater, it's bringing a lot of nitrogen with them. People always thought, well, it brings a weed seed with it. No, the weed seed's there no matter what. You just have to have something to trigger the growth. And
We're seeing, and I don't have it quite documented yet though, but when people are using a lot of nitrogen, like above 0.8, 0.9, test weights are dropping. You get your nitrogen efficiency right, and your test weights go up too.
I'm friends with Russell Hedrick, who set the dryland yield record last year at 459 bushel in western North Carolina, and his nitrogen efficiency is 0.42.
0.42?
And I mean, that's why I started tracking it, is when I talk with Russell, then he starts asking me those questions.
Yeah.
I don't know, I've never figured it out before.
Yeah.
And that's telling you that the biology is doing what it's supposed to do. So.
And you know what else is telling you? That the people recommending nitrogen are a little overstated what needs to happen.
More than a little.
Yeah. Yeah.
You say there's all these benefits of soil health, biological health in your soil. How do you know if you have a healthy field or farm or not? I mean, what are the outward signs, or is it all in a test? And if it's a test, what is the test? And what do you look for?
All of the above.
Yeah.
We will touch on this when Mark gets going here next. Mark has the ability to take a soil test, quantify the biology you have, find the shortcomings, grow you a prescription from your own to increase population, or if you don't have certain biology, he can gather that from a library to give you what you may be lacking. So we'll get into that a little bit more here shortly. What?
If your plant's getting what you need, then you're on the right track. And if you're making headway along the way, then you're doing the right thing. I mean, guys like Mark are figuring it out. There's so much to learn about it.
There is testing that you use for soil health. Who would you go to, and what test do you recommend?
He's just much more thorough in what he's.
See, I think that's the same question as which soil lab should you use, and that's why I mean, you can use any soil lab, and they're going to give you a different, that's why I say soil tests should be used as a trend line guide. You should use like same lab, same time of day, and make sure your trend line's going in the right direction. So I think the same thing is true with all these biological labs. There's a lot of good wisdom out there, and they're trying to figure it out. But, we've had a lot of luck with the Haney test, but a lot of people say, I get a Haney test, there's nothing actionable on it. What do I do? So,
No recommendation.
right, yeah.
When you talk about biology, I look at wildlife. We have more wildlife on our farm now than I could ever remember in my life. We got wildlife that hasn't been there ever. I remember the first time I saw a wild turkey show up.
Yeah.
And people ask me about what we're doing, and my comment is, if the wildlife is overwintering on our stubble instead of the neighbor's stubble, obviously there's something out there that they're getting that they don't get across the road.
We had a situation where driveway here, organic farm here, conventional farm here, deer tracks galore, no deer tracks here. It's like, right? It's like putting butter and margarine out in a hot cement, Insects know. I mean, animals are very smart in terms of what they eat. That is a good metric.